right, so Algebra Honors, we are looking at Unit 8 on quadratics, and this is day 5. So we are going to finish our notes on day 5. We had done problems 1 and 2 already, and we're just going to work on 3, 4, and 5 right now. So we're using Desmos to figure out the equation or function that we need to describe some data points. Okay, and whoops, I seem to have... Oh, there, now it all fits. Okay, so number 3, it says Dylan tosses a football. The horizontal distance D in yards. Whoops, I'm sorry. Well, hold on. No, we're not leaving. And we want to be back on these notes. No, we want to be back on those notes. Sorry about that. Okay, so my ordered pairs are going to be the distance in yards and the height in feet. Okay, so each one of these ordered pairs that we are given tells me the horizontal distance and the vertical distance. I am probably going to default to using X and Y when I'm using Desmos, just because I typically do. But keep in mind that we know each one of these ordered pairs is telling me about the distance, D, and the height, H. So when I look at this, my questions for this problem, it's given me some data, and it wants me to find the equation that represents that data. It's telling me all from the start that it's going to be a curve, so that's helpful. Then I'm going to want to find the horizontal distance that travels before it hits the ground, and I'm going to want to know how high is it after it has traveled 5 yards. So let's take a look at Desmos. Remember, these ordered pairs are giving me, I'm going to make an X, Y table. So I always have an X and I always have a Y. And I'm going to put these ordered pairs into the table together the way they show up in those ordered pairs. So I've already entered that into Desmos. This is not Desmos. Get out of there. Let me get myself to Desmos. There it is, sorry. So I've already entered these ordered pairs. So 0, 6, 3.2, 8.4, and so on, 6.4, 9.4. Those are my ordered pairs. Now, when I enter that into Desmos, you can see that it is making a curve. Right? You can see that curve that's happening, but also the problem itself told me to be looking for a curve here. When I want a curve, remember our quadratic function is going to be ax squared plus bx plus c. So I'm going to enter in, instead of y equals ax squared plus bx plus c, I want Desmos to figure out some things for me, so I'm going to do y sub 1. Hey Desmos, look in my table and find the A and the B and the C that works for all of these pretty closely. And so I plug in Y sub 1 and I plug in X sub 1. See how I've got those subscripts? Again, always remember that your subscripts up here at the top of your table match what you're doing in this equation. So the magic equation we need is Y sub 1 tilde A X sub 1 squared plus B X sub 1 plus C. And when we enter that, after we have given our data in, Desmos is going to figure out an A and a B and a C for us. I usually round this to the nearest hundredth unless I'm told otherwise. So I'm going to write that my A is negative 0.06, my B is 0.92 because I'm rounding, and my C is 6.02. So back on my notes, that's what I'm going to put. Okay, I know that A equals negative 0.06 because Desmos told me that, and I know my B equals 0.92, and I know my C equals 6.02. Again, I know that because that's what Desmos just told me. So I can write the equation, right? I know Y equals ax squared, so negative 0.06 x squared, plus bx, 0.92x, plus c. Okay, that is my equation that I'm going to use. Now, the next part says what horizontal distance does the ball travel before it hits the ground? If it hits the ground, I know y equals 0, right? That height is 0. So I'm going to solve negative 0.06 x squared plus 0.92x plus 6.02. And of course I could solve that using the quadratic formula, but I've already entered this into Desmos, right? And so if I show my curve, before I had my curve off, but if I show my curve, see how nicely that lines up? My curve, and And don't forget, you can click this zoom fit if you aren't able to see your dots when you make your table, okay? I want the zeros. So here's a 0, right at negative 4.944 and 0. And here's the other 0 at 20.0890. Okay, in general, we are not going to have negative distances and negative times. So I'm just going to use this ordered pair, 20.089, comma, 0. So that's going to be the 0 I care about. So back to my notes. The height, when the height was, the horizontal distance, when the distance was 0, I know that x equals 20.089 yards. I don't know why I wrote that, because I said I would round that to the hundredth, so if I round it to the hundredth, that's going to be 20.09 yards. Okay? Is this true? Yes, the horizontal distance is in yards, and the height is in feet. So I just wanted to make sure that I'm doing my right units. All right, so now I want to know what is the height if the football has gone 5 yards. So it has gone 5 yards, that means x equals 5, right? I can just plug that into my equation and figure it out. So I'm going to go back to Desmos with this value of x equals 5. I'm back to Desmos, clicking here. And so I've already typed it in just so that you don't have to watch me type it, but I typed in the equation that Desmos told me, and I went ahead and rounded. So our answers might be slightly different depending on how you rounded, but I wrote negative 0.06 times 5 squared plus 0.92 times 5 plus 6.02. I just substituted in 5 any place there was an x here. Okay, and so I got 9.12, which is, I'm going to go ahead and write as 9.1 feet in the air. So we know also that if I wanted to, if x equals 5, let's look at we have 5, 10, 15, 20. Each one of these gradations for my chart is right at x equals 5. If I click up here, that's when x is 4.8, 5.05. I can see that 9.12, 9.1 is about my right answer, right? See? 9.12 is pretty close. Okay, so we're going to say that it is 9.1 or 9.12 feet in the air, and I'm back on my notes, and I know when x equals 5, y equals 9.1 feet. Okay, so what height is that football after 5 yards? It is 9.1 feet, or 9 feet, or depending on how you've been told around. Okay, now Shelby kicked a soccer ball. And Shelby kicked a soccer ball. The time t in seconds and the height h in feet of the soccer ball are shown by these ordered pairs. So we're going to do the same thing. Again, we're going to plug all of this stuff into a table in Desmos. Sorry, I forget what app I'm using. So I suggest you try it on your own. So put the video on pause, try it, and then come back. Okay, so into Desmos I go, and I'm going to enter this data into the table, which I have already done, 0, 0, 0.3, 7.5, and so on. I'm going to click that plus to make my table, make my data points show up nicely for me on Desmos. Okay, and I can see that it's going to be a curve, so I'm going to ask Desmos to find me the curve of best fit. Okay, so I'm going to tell it y sub 1 tilde ax sub 1 squared plus bx sub 1 plus c. And here's the line of the curve of best fit, rather, right here, and that does fit nicely with those data points. So now I have an a and a b and a c that I can use for an equation. I'm going to round to the nearest hundredth, so I'm going to have negative 16.17, and I'm going to have 29.94, and here to the nearest hundredth, you can see I'm going to be negative 0.01. So when I go back to my notes, that's what I'm going to plug in. I say y equals negative 16.17x squared plus 29.94x minus 0.01. And again, this is A and B and C that I got directly from Desmos. I had Desmos tell me. Now, when does that soccer ball hit the ground? It hits the ground h equals 0, or y in this case, because we're using y as our height, y equals 0. So I set the whole thing equal to 0, right? So I'm going to look at my Desmos graph, and I'm going to have the graph tell me exactly where my zeros are. I have a 0 right here, 0, 0 is where I started, and then here's my other 0. And I'm going to click on it, and it tells me it is, sorry, I'm going to click on it so you can read it, 1.85, 1.852, 0. So I know that I want to write x equals 1.852 seconds. That's how long it takes for me to have y equals 0. Okay, I don't really care that it was also on the ground when I first started, right? So I'm not going to use that first 0. All right, now, what height is that soccer ball when x equals 0.6 seconds? I'm going to say the f of 0.6 seconds, or I'm going to plug that back into the whole equation. So I'm going to say y equals, I want any x I have to be 0.6. And so I'm going to just plug in what I have. I know a is negative 16.17. And I'm going to say x squared, so 0.6 squared. Okay, plus my b value that I just learned about is 29.94 times 0.6 plus my c value, minus my c value since it's negative, 0.01. Okay, I got these numbers directly from Desmos, so negative 16.17, and then I have 29.94, and I have minus 0.01. And of course this is x squared, and this is x. It is telling me that y, the height, is 12.13 when my x value is 0.6. Okay, 12.13 when my x value is 6. So, looking at my graph, when my x value is 0.6, that's right here-ish, right? If this is 0, this is 0.5, this is 1, this is 0.1, 2, 3, 4, 5. They're at 0.1 gradation, so right here, 0.6. That's my magic spot right there, 12.13, and that's what we figured out also. So we're going to go back down here to our notes, and we are going to say the f of 0.6 is 12.13. Okay, and so what that means is after 0.6 seconds, the height of that ball is going to be 12.13 feet. Okay, and again, if you didn't already do the very last one, go ahead and enter these two tables in one at a time. Just do them one at a time. Look at what the data looks like and try to decide whether you think it's going to be a line or a curve. And then once you decide that, I want you to go ahead and enter in the equation, figure it out. Okay, so I'm going to go to Desmos with just part A here. I'm going to go to Desmos. I'm Xing out of my other things here, and I'm going to clear out my table. So clearing out my table, and now I'm going to enter in from part A. I have 0, 2, 1, 1.5. I'm going to pause so that you don't have to watch me do that. Okay, so I've used the data table from our notes, and I've plugged in all of those data points. And so now I want to see what that looks like. I'm going to go ahead and zoom to fit by pressing that button. And, whoa, that certainly looks like a line to me. So I'm going to ask Desmos to tell me what the equation for the line would be. So the way I do that is I know y equals mx plus b is a way... I'm so sorry. Y equals mx plus b is our equation for a line that we love. So I'm going to tell Desmos y sub 1 tilde mx sub 1 plus b, because I'm asking Desmos to look in this table to find the best m and b that work. So remember that we just scroll down here and we see that our m, our slope is negative 0.5, and our b, we cross that y-axis right there at 2. So you're going to go to your notes, y equals negative 0.5x. So So y equals negative 0.5x plus 2. And this was linear for sure. We could really see with that data that it was linear. So that's why we used, I'm going to write it down just so you have it, y sub 1 tilde m x sub 1 plus b. We're going to use that equation. Okay, so now we're going to put this data in, and we're going to see what it looks like and decide whether we're looking for a line of best fit or a curve of best fit. So back to Desmos we go. And I've entered my data into this table. And so I'm going to use my zoom fit again. You can also use the wrench that's up the top right of your Desmos. All right, and so if I zoom fit and kind of look at all of this, it is looking like a curve, right? It's going to be an upward curve, and possibly my vertex is right there at the origin. So let's go ahead and ask Desmos to give us y sub 1 tilde ax sub 1 squared plus bx sub 1 plus c. Okay, oh, and that looks great. So once I put that curve of best fit in there, it does really look like it's hitting those points pretty nicely. So I have an A and a B and a C right here that I have gotten from Desmos, and I'm going to record that. A is 2.8, so let's go back to our notes. And that was definitely quadratic. We know y equals 2.8x squared. And then B and C were 0. Did you see that? So B and C were 0. So I'm not even going to put plus bx plus c, because it would be plus 0x plus 0, and that doesn't, we don't need to do that. Okay, and this one was definitely quadratic. We could see when we put our points in that it was making a curve in that quadratic fit very nicely. So, all right, those are our problems from our notes that we were working on. And I do have some classwork that I want you to try. So this classwork, there's the top of it. Sorry, this classwork, we're going to start at number 6. Okay, so that's not a mistake. You're just starting right here at number 6. We have a football is kicked into the air with an initial upward velocity of 82 feet per second. Its height in feet is recorded at various times in seconds in the table. So we want to write an equation for the curve of best fit. Write an equation for the curve of best fit. Then estimate the height when we have time equals 5 seconds. Okay, so I'm just going to do, probably just do this first problem because your key actually gives you information on the answers for the rest. I'm going to go ahead and do this first problem though. So we're going to go back to Desmos and we're going to enter in this table. Okay, so here I have all of that data from our football being kicked into the air written right here in my table. And I want Desmos to find the curve of best fit. So first I'm going to just make sure that makes sense. I'm going to do my zoom fit. I'm so sorry. And so you can see this is pretty definitely a curve, right? So I've got my equation still written in here, y sub 1 tilde ax sub 1 squared plus bx sub 1 plus c. If I turn that on, that is my curve of best fit. So I can see my A and my B and my C, and I'm going to go ahead and record those on my paper. And then I'm going to try to figure out what happens if time is 5 seconds. So this time I'm going to look right here. Time is 5 seconds. What is my x? If I click right there, oh, you can't see it. Hold on. If I click right here, if I move my graph, sorry, and make it bigger and move it so that we can see time is 5 seconds right here. Oh my goodness gracious, I am just a disaster. Hey, look at that. Time is 5 seconds. I'm going to click. Now you can see that I'm at 5.02, 5.01, 5. Oh, that's 5. Look, if my time is 5 seconds, it looks at my y value is 10. So let's use 5, 10. Let's try that. Okay. So back to here. I found an ordered pair that was 5, 10. And so that means at 5 seconds, height equals 10 feet. Okay, now I found a and b and c, and I was told to write an equation, so of course I know y equals ax squared plus bx plus c, so I'm going to say negative 16x squared plus 82x plus 0. I'm not going to write. I could certainly just plug in 5 squared, 25 times negative 16, and add that to 82 times 5. Okay, to get my 10. But since I already had it graphed out in Desmos, I didn't mind clicking until I figured out what is the y value when the x value is 5. Okay, so you're going to try 7 and 8, and you'll be able to check your work because your key is in Schoology. And then for number 9, it's the same idea. We just have horizontal data. So when you're entering this in, you're going to kind of have to transpose it so that you can put it into Desmos, okay? So if your x is 0, your y is 32. If your x is 15, your y is 48. If your x is 30, your y is 71, and so on, okay? So you're just going to have to transpose that data yourself into Desmos in order to get Desmos to understand what you're talking about. So great. That was our Unit 8, Day 5 classwork. And you should have the key in Schoology, and we are done with Unit 8, Day 5. Great job. Thanks for watching.